Hello, my name is Tolope Adewara. With me are my colleagues Shamas, Onye, Olasukomi, Bright, and Olakuni. We are Group 6 members making a presentation for Jumbo Delight Limited on a model database and business intelligence. The aim of this presentation is to develop a database system for Jumbo Delight. And the objective of the presentation is to provide Jumbo Delight with a database management system to enable the firm keep accurate and secured records of its customers' information, to give the firm access to staff information, to also allow the company track consumers' complaints and feedback to determine a way of servicing them better. And lastly, Jumbo Delight will be able to make data-driven and well-informed decisions. Now about Jumbo Delight. Jumbo Delight is located in Hatfield, England, and they are into providing fresh, local, seasonal foods to schools and colleges, inclusive of providing catering services to the academics. We went further to create a table for Jumbo Delight, and my colleague here would explain better on that.
Hi, I am Sharma Saj, and we have created a database for the Jumbo Limited, and for that we created two tables, and the employee table and the customer table. The employee table includes 18 attributes, and the primary key in this table is the employee ID. When it comes to the customer table, it includes 28 attributes, and the primary key is the customer ID.
My name is Sukomi Faniron. I'm here to talk about normalization. Normalization is the process by which data are being analyzed for anomalies or inconsistencies in the relations. So we have the employee table and the customer table. And in this, we make sure these tables pass through the process of normalization to be able to get a final normalized table. And part of the normalization process is that we run them through the normal forms. The normal forms involves the first normal form, and after passing through the first normal form, we ensure that it runs through the second normal form. In second normal form, we make sure that every value, we ensure that the table satisfies the first normal form and the table does not contain any partial dependency. Then we run the tables also through the third normal form. The table passes through the third normal form by ensuring that the second normal form is achieved, and also that there is no transitive dependency. This is the employee table that also passed through the second normal form. Then we have the employee table as well that passed through the third normal form, and which gives rise to the other tables that we can see below.
Thank you. My name is Bright, so I'm here to talk about the final normalized table. So this is the final normalized table that I've passed through the first, second, and third normal form. And this table will help Jumbo Delight to make a very good and accurate management decision. So here we have the customer table and the employee table that has been finalized, that has gone through the final normal form. Then we have the SQL queries. So we run an SQL queries on some of the tables using the customer remark table. The queries we ran gave us these are the query reports that we got from the queries, and we used some identifiers, the remark info and the service quality, using the employee ID also, and this is the code generated running the tables. Now this is the form also from the tables query that we run. We got the report generated from the customer feedback report. Now I'm going to hand over to my colleague to talk about the AR diagram.
Okay, so hello, my name is Onyinyechi. After the tables have passed through all normal forms, we proceed to representing them to showing what the relationship is using an ER diagram. it's a visual depiction of data showing how one data is shared and connected to the other. So for instance, we have all our tables represented, and what connects with each of these tables are the primary identifiers, the unique identifiers, which are the primary key. So you can see here that the customer ID directly connects to the customer ID in this table. You also need to note that in a table, we have a primary key, but when it moves to another table, it becomes a foreign key, which is what we have here. So when we do this, we now have to convert this this conceptual representation. We have to convert it to a model that we can directly implement in a database. And to do that, we have used the crow's-foot notation. From here, you can see how each table is directly connected to the other. For instance, we have the customer table and the order table. The customer table has a line that is directly linking to the order table. And you can see that there are, according to the crow's-foot, there are 3 crow's-foot coming from this, which means that multiple orders can be made by one and only one customer. So there are a lot of other explanations you can get from this. I'm going to present this to my colleague now for our recommendations. Thank you.
Hi, I'm Olakunle, and I'm here to give you the recommendations that we have for Jumbo. The first one is to provide incentive packages that will attract more student customers for them. And the second recommendation that we have is they should develop a program on customer relations, and they should invest in their human resources in order to enhance the quality of services that will be rendered to their customers. And thirdly, we advise them to stock up on the products that are moving and generating the most money, as those are the ones that the customers like buying. And also, we'll tell them to conduct a survey on the meal preferences of their male customers in order to attract more male customers to their loyalty programs. And lastly, we'll ask them to implement more employee incentive packages based on their sales, as that will enable their employees to perform better. And I'll also be showing a list of our references for this presentation. Thank you very much for your time.